Today, then, we are on our 4th day of proofs, and you have a notes page to make this go a little bit faster. We're going to focus on a little bit of vocabulary first, and then a little bit of review, and then a couple of proofs. Bisect, bi means two, sect like dissect, intersect means cross, cut into, two equal parts. So you can bisect angles, you can bisect segments. It means cut it into two congruent parts. So if we have an angle bisector, it goes through the vertex of an angle, and this blue line cuts my black angle into two congruent angles. So if I wanted to label that, so let's suppose this was AB, and then I'll let my angle be CDE. So add your labels to your pictures. Let's suppose we are given that ray AB bisects angle CDE, or you could call it angle EDC, but D has to be the middle letter, and your reason would be given. So if we have that in our proof, we are going to be able to say it means these two pieces have the same measure. So we can say angle CDB is congruent to angle EDB, and that's probably what would be my corresponding order. And who wants to take a guess of what our reason's going to be for that based on some other ones that we've done? What do you think, Ada? Or just definition of bisect. It's fine to say definition of angle bisector, but we could also just say definition of bisector, cut it into two equal pieces. And we'll start doing that in some of our proofs. As you see on your next picture, and as we talked about on that one homework question, we can also bisect segments, and that means it's going to go through the midpoint, or it's going to cut that segment into two congruent parts. So again, let me add some labels on here. Let's let this be A, B, C, D, going all the way around, and then I'll let this point here be E, where they cross. So if we are given BD bisects AC, BD cuts in half, BD cuts the other one in half. That means it cuts it into two equal parts. So that means AC is congruent to, well, I'm sorry, not AC, AE. Let me try that again. AE is congruent to CE. And who wants to guess what that reason's going to be? Wyatt? Definition of a segment bisector, or again, just definition of bisect. And I want you to write yourself a note on this one. AC does not bisect BD in my picture. Do you understand how the English language works, so that you label the correct part? Because sometimes in the proofs, maybe it'll end up that they really do both bisect each other, but you aren't given that, and you have to make sure you use the right one. Or maybe they're close, so close that it looks like they bisect each other, but they don't really. Questions with that? Right, look at the parallel lines now on your paper. And we have 8 angles in there. And I want you to add a little arrow symbol to each of the 2 horizontal ones to say that they are parallel. Now, out of those 8 angles, if I knew the degrees for each, how many different numbers would I have in there for the degrees? How many different angle measures are there? Are all 8 angles different, or half of them are the same, or How many do you think, how many different angle measures will we have? Griff? And so which ones do you think would be 4 different ones? And you don't think anything out of 1, 2, 3, and 4 could be the same? So you're thinking 2 different angle measures. I saw some people with 2 fingers up. Is that the consensus? If those are parallel lines, we automatically know all of the acute ones have to be congruent to each other. And we know all of the obtuse ones have to be congruent to each other. That's the easy part. Now, if we pick any 2 that have the same measure, we have to come up with the right reason for them to be congruent. So, alternate interior angles. Who can tell me 2 alternate interior angles? Ada? Everybody good with 3 and 6 would be 1 pair of alternate interior angles? And they would be congruent because they are alternate interior angles. They are interior, they are inside the parallel lines, but on opposite sides of the transversal. Are there any other sets of alternate interior angles? Nicole? Everybody good with 4 and 5 are also alternate interior angles? And we will continue to abbreviate that with AIA as we do proofs. Alternate exterior angles. Can anybody tell me 2 alternate exterior angles, either both marked in blue or both marked in green? Griff? 7 and 2 would indeed be alternate exteriors on the outside of the parallel lines and different sides of the transversal. Are there any other sets of alternate exteriors? Ellen? 1 and 8 would also work. And we can continue to abbreviate that, alternate exterior angles. Corresponding angles. Remember, these are ones that are either, if you think of the 2 intersection points as intersections, both of the angles are on the northwest corner, or both of them are on the northeast corner. Or if you prefer to think about it, they're both bottom left or they're both top right. Look at the picture on your paper and tell me 2 that you think would be corresponding. They'll both be marked in blue or both in green. Leah? So 4 and 8 would indeed be a pair. 4 and 8 were both bottom right angles. What else, Abby? So 3 and 7. I'll just take a peek at my picture. Yes, 3 and 7, both marked in green. They are both southwest or bottom left. What other ones? We've used 3 and 4 and 7 and 8. So we've done everything that's a bottom angle. Caleb, tell me another set of corresponding angles. We have done 3 and 7. We've done 4 and 8. Everybody good with 2 and 6? And what else? What besides 2 and 6, Yesenia? 1 and 5. Excellent. Any questions from anybody on those? All right, let's do a proof. You already have the picture drawn. You do not need to copy it. So start your T-table and go ahead and fill in your first 2 lines of it. Remember to write statements and reasons. But I am assuming you have no trouble at all doing statements 1 and 2 right now. So Jack, help us out. What are you putting for 1 and 2? parallel to. And then what else do we do with that information? We need to put it on the graph. So let's mark Q and S. PQ is parallel to, sorry, that looks like two little teeny tiny parallel lines. That's what it means. So we find PQ. Is that left, right, top, or bottom of the parallelogram? So PQ, that's on the left. Where's SR? On the right. So you need to do an arrow on the left and an arrow on the right. It doesn't matter if they point up or they point down, whichever way you'd rather draw them. But we need to remind ourselves those are parallel. So all we have about the triangles is one set of congruent angles. We are supposed to prove that the left and the right are congruent to each other. So since those are parts, that sounds to me like we need to get congruent triangles and then use CP/CTC for that final step. So I have to figure out how to get congruent triangles. Anything else we can figure out and say about those two triangles? Madeline? And so, hey, the two triangles share that, and we know that is the reflexive property. And so I know PR is congruent to itself, but right now, I'm not sure if I'm supposed to keep it PR or flip it to RP. So I think I'm going to leave it blank for a moment and then come back and fill it in. So now we look at our picture and we have one set of sides, one set of angles, and we need more. The only other thing we have to work with are those parallel lines. I must have told us that for a reason. So parallel lines, and if it helps you, make them go farther. And then I would like for you to look at this line through the middle as a transversal that goes between your parallel lines. Now, you're doing notes on this sheet of paper, so twist your piece of paper so that your parallel lines go left and right, since you're used to looking at pictures with them going left to right. And now I want to look at the things that I have traced out in red and green. I've got two triangles. Are there any angles in those two triangles where I've colored both sides with red and green? Wyatt, you're nodding your head yes. What's something in the top triangle that I have marked both sides on it? Everybody good with that one? Is traced by the two parallel lines in that transversal? What about in the other triangle? Is there anything that's now that I'm thinking about with those red and green lines? Emily, what other angle? Is everybody good with this one up here? And the way you have your picture twisted, can you tell me a reason? We've just reviewed reasons why those two angles would have to be congruent. Madeline? Not yet. Save that thought for a minute. Right now I'm trying to give a reason for my second set of angles. You're thinking ahead to my third one. I've said they have to be because of those parallel lines, but I haven't put which one of those things, AIA, AEA, or CA, that we just finished reviewing. Caleb? Are both of those angles inside of the parallel lines? So they're both interior angles, and are they on opposite sides of the transversal? So I am going to say AIA to say those angles are congruent. So I'm going to look at the top triangle, and I'm going to call that angle QPR. It's congruent to, and then the other one needs to have R as its middle letter in that bottom triangle. I'm going to try to go ahead and line these up in the correct order. So when I wrote QPR, I started at the blue 1 tick mark, went to my alternate interior angle, and then went over to R. So in my second one, if I start with my blue 1 tick mark, that means I'm starting with S. and then going to R, and then going to P. So now I have those vertices lined up in corresponding order, even though I'm only talking about the angles that we've marked with 2 tick marks. That means I can say, oh, T, then R, second, third letter for my step number 3 has to be congruent with second letter, third letter, but now it's RP, so yes, I do need to flip them. Now we have reasons for 2 sets of angles. So now what were you thinking ahead to, Madeline? Excellent. So we'll get our third angle in here. AA implies AAA. And we need to write down what that angle is. Any way at all that we want to name it in the top one. So how about QRP? Is congruent to. I know I got the letters in the correct matching order for number 4, so I'm going to use that to help me here in step 5. Q, I kept the same first letter, so I'll keep the same first letter of the second one. But in 4, I had PR, now I have RP, so I flipped them. In 4, I had RP, I'll flip them, and now I have PR in there. And I have named my 2 purple 3 tick mark angles. Do I have enough mark to say they're congruent for the triangles? What do we think? Ethan, what's my reason? We have 3 sets of sides marked now and 1 set of angles. So we know that the triangles are congruent, and I can stick with my QPR and my SRP. So now we know congruent triangles, and we are hoping the left and the right are corresponding sides. PQ on the left, so I'm going to write that down. And I'm going to look, that is second letter, first letter. Second letter, first letter is RS. And is that what I wanted? Yep. And what's the reason? CPCTC. Anybody with a question there? All right, turn your papers over and we'll do the next one. So you've got the picture. Draw your T-table. Statements and reasons. And begin by writing down the givens. I think you know that by now. And we want to try to mark things on our picture. ABC, that's my angle up here. ADC, that's my angle down here. They're congruent. AC, that's the line through the middle, cuts the big outside angle in half. So that tells me that these 2 are going to have to be congruent. So I need to actually write that in my proof, that angle BAC is congruent to angle DAC. And I knew to go in that order because B had my 1 blue tick mark on it. And in my bottom triangle, D has 1 blue tick mark on it. So I put 2 tick marks on those. And who can tell me my reason for that? What's my reason for that? Griff? Perfect definition of bisect. Again, I'm trying to prove that 2 parts are congruent, so I probably need congruent triangles first. I have 2 sets of angles. What else can I get so that I'll be able to say that the two triangles are congruent? Ada? Excellent. So we'll say angle, angle, since we have two sets, means the third set of angles has to match up. So we'll mark those, and we'll write it down for the top triangle as angle BCA is congruent to, B had one blue tick mark in the top triangle, D has one blue tick mark in the bottom one, D to C to A draws the angle I'm talking about. Do I have congruent triangles yet, Jack? How do I get that? Okay, so we're going to say the line through the middle of the whole picture is the same as itself because of the reflexive property. And that is the line that goes from A to C. And if I look at my statements here, well, the one just above it, A was third letter, C was second, A was third letter, C was second, same order, so I don't need to flip it. Could also think about it as AC goes from 2 tick mark angle to 3 tick mark angle. Same thing for the bottom triangle. Now do I have enough to have congruent triangles? Austin, what do you think? And what would be my reason? What all's marked on my pictures? Perfect. So now we can say that the triangles are congruent. Angle, 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 side. And triangle, oh, I'll just go ahead and call it ABC. And then I need to look up here. So A had 2 tick marks, and in the bottom, A also has 2 tick marks. B was my next letter. It has 1 tick mark in the top one. D has 1 tick mark in the bottom one. And that leaves C. And the C's both have 3 tick marks. So will BC and DC be corresponding sides of those triangles? Because that's what we want to show. One way of saying it is they're second, third letters, so yes, they're corresponding sides. Another way is BC is across from 2 tick marks, and so is DC across from 2 tick marks. So BC is congruent to DC, and what's our reason? Corresponding parts of congruent triangles are congruent. CPCTC. Any questions?